Hi, everybody. My name is Dr. MacKenzie Bolen, and I am a very proud neuroscientist. My credentials include a pretty cool Ph.D. in biomedical sciences, and having spent a substantial amount of time interacting with the US medical system following a head trauma. Now, that's where my curiosity in the brain really began. I got to share my experience as a long-term patient on the TED stage a few years ago, and I encourage my fellow neuro nerds in the audience to go check that out. However, today we're going to analyze the use of artificial intelligence, or AI, in research in medicine. We will decipher if machine learning medicine is actually artificial or intelligent. But in doing so, I hope to convey to you that AI will not replace the physician-patient interaction. But it is becoming a very important tool, from frontier-level scientific labs all the way to your doctor's office. I will share my opinion that the use of AI in medical care should absolutely be done with ethical consent. And my final point is that AI isn't just coming to medicine. It's already here. So, when I started my PhD, I had no idea how much AI was already being used within the biomedical sciences. And I very quickly learned that we were in a bioinformatics renaissance, and AI was the tool being used to sift through these ever-growing data sets. And as I, and likely many of you in the audience, have been forced to get up to speed with this technology, we first have to ask, what is AI? Well, the word intelligence and artificial intelligence indicates the ability of AI to mimic human choice. However, as the title clearly describes, AI is artificial, meaning a human component is required for this tool to be helpful. AI is a computer system built of algorithms that contain code that act as instructions to create different types of models. One really popular type of model is ChatGPT. And when you ask ChatGPT a question, it references a massive input data set and uses it as evidence to mimic problem solving and decision making. Now, as it's sifting through that massive input data set, it will predict the most probable pattern or outcome to your question. And these tools are truly phenomenal at pattern recognition and data processing. And they're so valuable because they do this in a fraction of the amount of time it would take us to do the same task. So, is AI intelligent? Oh, absolutely. However, there is a very critical need for the output of these models to be much more accurate, especially in the context of medicine. And scientists are using their human intelligence to drive that work. So flashing all the way back, when I started my PhD, and what has now become the entire objective of my career, is to identify early in life biomarkers of age-related brain disease. And as I, and many other neuroscientists in my field, have struggled to parse out these very elusive questions, we hope AI may be the tool that helps us answer them. I really started to tackle these questions in the second year of my PhD, when I started to dabble in multiomics. And multiomics is a new-ish technology that uses really high resolution to investigate molecular imaging and expression. And at the time, so roughly 4 years ago, there were only 13 active machines in the country that could investigate the biosamples that I had at the multiomic level that I needed. And I was lucky enough to get to work on one. So I had 4 microscope slides. And if you hadn't had the absolute privilege of working with microscope slides, they're about the size of those pink erasers we all used to chew on in grade school. Maybe just me, okay. And so I submitted my 4 slides, and it took the machine 90 hours to analyze them. And from those 90 hours, 4 terabytes of information was generated. And to put the volume of those data into perspective, 1 terabyte of text information is equivalent to 353,253 copies of the Webster's English Dictionary. I had 4, so that's roughly 1.5 million copies. And to continue to scale those data to size, if I had stacked every single dictionary, one after the other, all the way to the top, it would have reached the absolute top of the Empire State Building 344 times. And you may be asking yourself, how did you even start to analyze all of that data? Well, I will tell you that if you try to open a data set with more than 1 million rows, it immediately crashes Excel. So, once I restarted my computer, I very quickly looked to AI, and it worked. I was able to make biological meaning out of millions of molecular data points. And many other neuroscientists are doing the same with their own data sets. And I know it sounds counterintuitive, but we are making some very precise and refined conclusions from some of the largest data sets we've ever analyzed. So thus far, I've really only talked about how we can use these algorithms in a lab setting. But how could they be used in the clinic? Well, I promise your doctor is not going to turn into a robot, but the tools that they use within these interactions are drastically changing. So, you've probably had your blood drawn before. Maybe you've had genetic testing done. Maybe in a more complex case, you had PET or magnetic resonance imaging, also known as MRI. Well, we can take those images, combine them across thousands of patients, and build prediction risk modules. We can look at the changed architecture in your image and predict risk of disease. So in 2017, the US FDA approved the first prediction risk module for heart disease risk. That was 8 years ago. But there are other ways we can leverage AI in medicine as well. There's also voice ambient recognition software. And what is that? Well, it acts as a scribe. There's been a lot of mixed feedback about this, and we can see both sides. On one hand, a provider could be very grateful to be able to fully focus on their patient. On the other hand, a patient could feel uncomfortable with an AI algorithm transcribing and possibly storing their medical information. So, no, a robot is not going to replace your provider. However, the integration of AI is rapidly changing and has led to the optimization and advance of one of the most private and vulnerable interactions we can have, our medical care. And this leads me to my next point. There is already a lot of mistrust in the US healthcare system, and the integration of AI has only amplified public skepticism. I mean, we've all heard of AI going wrong. Here's an example. A recent New York Times article came out saying that an AI algorithm used to predict health risk was racist. The title is absolutely correct. The output was racially biased. And you may be asking yourself, how could a computer system output a racially biased response? Well, here's the answer. This algorithm was trained on large portions of the internet, which contains human history and media content. So it makes a lot of sense that the algorithm did its job almost perfectly and predicted the most probable pattern, which included racial bias. Not only are there issues with mistrust in AI use in medicine, there are also very large issues with lack of privacy. The integration of AI into medicine has led to a very slow response of both state and federal legislature. There is no normalized consent process to AI integration into your care plan. And this has led to us fearing that there may be some loss of autonomy for patients. And as a neuroscientist who has used AI in medical research in the past and likely will continue to use it, I sit extremely uncomfortably with this. I see two major problems. Are patients willing to consent to their anonymized data being used to train AI algorithms? 2, if they do consent, does the output of the algorithm actually improve their quality of life? So, as I continued my research, it became very, very clear there wasn't much of a community aimed at tackling this problem. And I decided that I was the one to fix it. So, I gathered scientists and physicians and other types of providers. I gathered attorneys and some of the most important scientific members in my community, the patients. And you know what's really funny? When you put a whole bunch of smart people in a room and ask them what they think about the ethical dilemma of AI implementation into medicine, we come up with some crazy ideas. And so we have re-envisioned the traditional consent paradigm. And my collaborators and I are working on making sure that all patients get the opportunity to provide consent on their anonymized data usage to train AI models. So, in conclusion, these data sets are ever growing. In order to have a quality output, you always need quality input. 2, as we learn more and more about this technology, it is absolutely required that we collaborate and work together to inform the best decisions. You need to take your scientific questions and leverage these tools so you can find out for yourself if they're truly productive. Patients deserve to take an active role in their care plan, and that starts with consent. My final point, and if you take only one thing away from my talk, is that AI will always be artificial. And if we use our conscious intelligence, like obtaining ethical consent, then we will be able to guide this tool to changing the landscape of both science and medicine. Thank you.